Okay, so today's lesson is on functions, and the basic description of a function is a collection of ordered pairs, x, y points, where each x is matched up with exactly one y. No x can be paired up with more than one y. So if we have any collection of points, it's automatically considered a relation, but a function is a special kind, and a function is one where each input has exactly one output paired with it. When we talk about a function machine, we think about like a soda machine. My set of inputs, or x values, each input that I choose gives me specifically one output with it. Now I can have a lot of different things that give me the same output. That would be like having a soda machine where you have multiple buttons that give you the same soda. This is okay. But what is not okay is one where a particular button gives me two different things out. Something like this would not be okay. This would not be a function, one where this x value gives me two different y values. So if we look at our examples up here, you can see that in this particular example, I've got my inputs of 2 and 5 and 6 and 2 again. This right here is the piece that is startling because 2 gives me 3 out, but here 2 also gives me 6 out. So this is not a function. I can still talk about the domain and the range of this relation. The domain is the set of all x values, and the range is the set of all y values. And so I can say that the domain of this particular relation up here, let me slide this one down, the domain of relation A would be, we'll do it like this. Domain is 2, 5, and 6. I don't have to list the 2 again. And the range here would be the y values, so 3, -1, 0, and 6. But this one is not a function because of that x value that has two different y values. Notice with my second example here, I see my domain has the values 6 and 4 and 2, and since none of them were repeated, I know that this one is a function because there's no x value that's repeated. My domain of this function is 6, 4, and 2, and my range here is -1, 3, and then the -1 that's again, I don't have to list it again. Notice we don't have a problem with the same output showing up again, it's just when the same input shows up. When I'm looking at a graph, I can see kind of the same thing. For any point on this graph, I can see the x value, and I want to make sure that there's no x value that matches up with more than one y value. So anywhere along this x-axis, if I look up or down, I should see at most only one point that would match up with it. And that's the case here. Now, in terms of domain and range of this function, so we said this is a function, but in terms of domain and range, domain is what x can be. And you'll notice the arrows here mean that it's going to keep going this way. So it's going to keep getting further to the right. And this one shows it's going to keep getting further to the left. So my domain is actually all real numbers, meaning that I can go as far to the right and as far to the left as possible. And there will always be a point that I could find on this graph with that x value. My range, on the other hand, you'll see that I've got this curve and there is a lowest point, and the lowest height that I ever get is a y value of 1. Every other point on this graph has a y value somewhere above that y value. And so my range is all the y values that are greater than or equal to that lowest y value. And there we're using our inequality notation from last unit. Our last one here is a circle, and you'll notice this circle, because there are certain points where if I pick an x, I can find two different spots on that graph with the same x value. That means there's going to be two different points where this first term, the x value, will be the same and have two different y values with it. So this one is not a function because of that. because I can find an x value with more than one y. However, I can still talk domain and range. So my domain for D is what x can be. And you'll notice there is a farthest left-hand value, which is over here, and it goes all the way over to a farthest right-hand value. Every point on this graph has an x value somewhere between 0 and 4. And so I would say my domain is all x values between 0 and 4. Or in other words, x has to be greater than or equal to 0, but has to stay less than or equal to 4. There's that compound inequality notation we used last chapter. X is between 0 and 4. The y values, or the range of this graph, the y values, you'll notice I go as low as -1, and every point on this graph is somewhere between that and the highest value of 3. You can kind of think of it like if we look at the light or a shadow that would be cast by this graph. If we squish it, we take this thing and just squish it onto the y-axis, every point on this graph is going to fall between -1 and 3. And so our range here, we would say, is all y values between -1 and 3. And again, we use this notation: y is greater than or equal to -1, but y is less than or equal to -3. We say that y is between those two values. That's my range, and here's my domain. Now, this domain and range, and whether something's a function or not, that's going to be an advanced skill for our benchmark. It's not something that you have to master for this benchmark. Understanding function notation, though, is a mastery level skill. You do have to know this. So function notation is written like this. You read it as f of x, or c of m, or h of r. And what that means is the rule itself is called f. The input of this rule is the variable x. And then there's an equation or an expression over here that tells how to get your outputs. So maybe f of x is 3x plus 2, meaning whatever you put into this rule, you're going to multiply it by 3 and add 2. C of m maybe says take m and square it, and then subtract 5 times m. So here in this particular rule, I'm going to input a value in 2 different places. One here for the m that gets squared, and one here for the m that gets multiplied by 5. And then finally, h of r, my input here is r, so in my rule I'm using a variable r, and maybe h of r says take r minus 3, find the absolute value of that, and add 1 to it. And so that would be how I would find the output. Notice there's only one spot here to input a value. So my 3 rules here, essentially, my rule F says the same thing as y equals 3x plus 2. My rule C says the same thing as y equals m squared minus 5m. And my rule H says the same thing as just the absolute value of r minus 3 plus 1. The notation f of x just means the same thing as y equals. It just says give me an output. But the notation allows us to quickly identify which rule we want to use. So when it says f of 3, it means go to rule f, and everywhere you saw an x, you're going to put a 3. So this says 3 times x plus 2, and we're replacing all x's with 3. So I'm going to replace the x here with a 3. And then I just simply go through and evaluate this expression. 3 times 3 is 9, plus 2 makes 11. So f of 3 equals 11, or another way to write this is when I input a value of 3, I get out a value of 11. Notice I can keep going with this. This one tells me to use rule C, and I want to input everywhere I saw an m, I'm going to input -2. So I'm going to put -2 gets squared, and then I'm subtracting 5 times -2. So the first thing I'm going to do is my exponents. That gets me a positive 4. Then I'm going to do my multiplication. That gets me a -10. Now I'm subtracting a -10. That's add a positive. And I get that C of -2 equals 14. Again, this is the same thing as saying when I put in -2, I get out 14. Couple more here, h of 0, so I'm going to go to rule h, and where there is an r, now I'm supposed to use 0, so I go to my rule, and instead of writing r, I'm going to write 0. -3 is in absolute values, then +1. So starting inside my grouping symbols, 0 minus 3 is -3. Then I'm going to take the absolute value of that and get 3, and then I'm going to add 1 and get 4. So h of 0 is equal to 4, and again I can say that when I put in 0 I get out 4. Finally, this one's a little bit more challenging. It says to find the value of f of 4 and add it with the value of c of 5. So I've got a couple steps I need to do here. The first thing I'm going to do is figure out what is f of 4. F of 4 is found by taking 3 times 4 plus 2. If you go back up to our rule f up there, everywhere I saw an x, I'm going to replace it with that value 4 in this case. C of 5, if I go to rule c, it says that I'm going to replace, everywhere I saw an m, I'm going to replace with a 5, so I'm going to use 5 squared minus 5 times 5. So now I'm going to come down here, find f of 4, that's 12 plus 2 is 14, so that's what f of 4 is. And c of 5 is 25 minus 25, so c of 5 is 0. And so then f of 4 plus c of 5 would equal 14, that's what f of 4 was, 14 plus 0, because that's what c of 5 was 0. And so the answer to this problem here, what is f of 4 plus c of 5? The answer here would be 14. Now, this one I can't write in the other form like I did the other ones because I'm not looking for just an input-output. I'm saying take the output of this and add it with the output of that. And what do you get? And that's it. That's everything you need to know about functions. So